Hey guys, I'm back for the quiz review for Unit 6. This is the second part. On this question right here, this is how we derive the equation of a parabola given a focus and directrix using the distance formula. Okay, remember I told you that you would be required to know this. This is how it's going to be presented on the test. I'm going to have some work shown. This is Sally's work. You have to tell Sally what to do next. So first off, the next thing that Sally needs to do is she needs to take these two binomials and she needs to multiply them out. So I would say Sally needs to multiply the binomials. Now you can use whichever you prefer. I've shown you the box method before or the FOIL method. So just as an example, I'm going to do the box method on the first one. So that would be y plus 3 and y plus 3. So y times y is y squared. Y times 3 is plus 3y. 3 times y is plus 3y. And 3 times 3 is plus 9. So when I combine my like terms, I get y squared. 3y and 3y is 6y. And then 9. Okay, so we're going to go back over here to our work, and we leave the left side alone for quite some time actually. So y plus 3 squared is actually going to be y squared plus 6y plus 9. Now the y minus 1 squared is y squared minus 2y plus 1, using the same method that we did up here. The next thing that we have to do is to distribute the negative sign to each term to the right trinomial. So again, leave the left side alone. This time we're going to distribute, so negative y squared, negative 2y is a plus 2y, and negative plus 1 is a minus 1. Now on the right hand side you're going to combine like terms. Y squared plus y squared, negative y squared goes away because that is 0. So 6y plus 2y is 8y. 9 plus the negative 1 is 8. Now the last step is to pull out whatever number is in front of y. So we're going to factor out an 8, so I get y plus 1 on this side with an x minus 3 here. Okay? So now I need to get rid of this multiplying by 8, so I would times both sides by 1/8. And that is your final answer. 1/8 x minus 3 squared equals y plus 1. Alright, next problem deals with graphing in the coordinate plane and proving that something is what it is. So we're going to begin by plotting the points. First off, A is at -3, -1. B is at -1, +2. From there we go to 4, 2. And from there we go to D, which is 2, -1. We will then continue and connect that line there to finish our quadrilateral. So this is A, B, C, and D. Now, based on this picture, we have to look at the slopes before we determine anything about it. Take a look at line AD and BC. Those are parallel because their slopes are 0. So you could say BC, is parallel to AD because their slopes are the same. Because their slope equals 0. Alright, now we check the slope of AB and DC. Remember, rise over run. We go up 3 over 2. The slope of this is 3 over 2. And the slope of DC, up 3 over 2, is also 3/2. So AB must be parallel to CD because their slopes equals 3/2. So that's the first part. We already know that this is at minimum a parallelogram. Okay? Now we need to check to see if it's actually a rhombus. I can look at these angles and pretty much say that's not a right angle. That's what's nice about proving in the coordinate plane, is we can look and see this is a right angle right here, but we are farther open. So that angle B is going to be larger than 90. Therefore, it's not going to be a square or a rectangle. So let's go ahead and check and see. Is AB equal in length to BC? Well, BC's length is easy to count. We just go 1, 2, 3, 4, 5. So the distance of BC is 5. AB, remember we can use Pythagorean's theorem. So this is 3 squared plus 2 squared, and you would square root that. So AB is the square root of 3 squared plus 2 squared, okay? And that would give me the square root of 13. Because 5 and 13 are not the same, this is not a rhombus, therefore it is a parallelogram. Okay, you must support your answer mathematically. Some of you will forget to do that on the quiz. Alright, now it says to draw the diagonals of A, B, C, D. So I'm going to get a line tool over here. Give me just a second. Let's do a different color. Alright, and we're going to draw the diagonals from A to C and B to D. Now, taking a look, we can assume that where they intersect is going to be somewhere right here. It's not a nice even number, so it's our job to find out. We need to do the midpoint of each. So the midpoint of BD is going to be -1 plus 2 over 2, comma -1 plus 2 over 2, which would give us 1/2, comma 1/2. AC, take the points A and C, add the x's, divide by 2, add the y's, divide by 2, because that's the midpoint formula, and you get 1/2, comma 1/2. So because these are the same, because the midpoints are the same, the diagonals bisect each other. Alright, and then our last problem is actually going to end up being a bonus on your quiz. So first off, it says we need to have a problem that opens up and the vertex is in the second quadrant. So let's go ahead and put a point anywhere on the vertex. I put my point at -5, 4 for the vertex. Now, in order for the parabola to open up, remember the focus must be above the directrix. So pick something easy. That could be our focus. Okay, and this line here will be our directrix. Okay, so let's go ahead and write the equation for this, listing that the focus is -5, 5, and the directrix is y equals 3. So our equation, we need h and k. So the vertex here was -5, comma 4, or no, yep, -5, comma 4. Yes, it is. Alright, and now we need to find P. Remember, P is the distance from the focus to the vertex. All I did was went up 1, so that's why I chose that to be nice and easy. So remember, to plug it into the formula, we have y minus k equals 1 over 4p, that's a y there, times x minus h squared. Replace k with 4. Replace p with 1, so 4 times 1 is 4, and replace h with -5, so this turns into a +5. There is the equation. There are multiple answers to this problem. Here are some things you need to look for. You need to look for a positive p-value because that means it opens up. You also need to look for a vertex in the quadrant 2. Okay, that would be over here. And then you would also need a directrix that's below the focus, that way it will open up. Okay? So then you could take the time and you can graph this. I've already done the points, so it's actually pretty much done. So I'll go ahead and graph that for you. Alright, so that would be our parabola with the focus and the directrix. You'd have to do all of this in order to get full credit for the bonus. The bonus will be worth 5 points, okay? So the equation goes in this little slot right here. Alright, that's it for the review. If you have any questions, I'll be here about 8:10, and you can ask me those questions in the morning. Thank you.